Okay, in this lesson, we're going to be looking at something a little different. We're going to be talking about what are called covalent compounds. And these are going to be a little different. So I want to make sure we understand what we've done before we move into covalent compounds. All the other ones that we've been doing up until this point are called ionic compounds. An ionic compound is when we took somebody from this side of the chart and we put it with somebody from this side of the chart. Maybe you would have +2 and -3, and you would switch the charges. That's what we did in the last lesson, or +1 and -1, or a +3 and a -1, where you switch the charges, and we learned how to name them. Things that ended in nitrogen would be nitride, oxide, fluoride, sulfide, phosphide, bromide, iodide. They're pretty easy to name. Those are ionic because they had ions, and that's what all of these charges dealt with. But today we're going to talk about something different. We're going to talk about covalent compounds. Now, just a quick reminder, you can tell by looking at the chart, everybody in this column's +1, everybody in this column's +2. These two guys were +3. You should already have these on your chart. 0 and -1 and -2 and -3. We figured out their charges because of what they wanted to do with their electrons. But we skipped carbon and silicon. Well, let's talk about those guys today because they are covalent compounds. And with covalent compounds, they do something different. Let's see if we can figure out what happens. Let's take carbon, for example. Carbon is element number 6. So if we drew a carbon atom, you would have 2 in the first and 4 in the outside. Now the problem with this one is that it has 4 electrons and 4 empty spaces, and this is what we did in the past. Well, we try to be full, and to be full you're going to have to do one of two things. In this case, if you threw away 4 electrons, you'd lose this ring and you'd be at a full ring. Or if you gained 4 electrons, the same thing would also be true. Gaining 4 or losing 4. Neither one of them seem like they're easier than the other. So up until this point, we have skipped them. So let me redraw it and show you exactly what happens. You take that carbon, and it has his 4 electrons. I'm going to draw them like this. 1, 2, 3, 4 electrons. And we just said he had 4 empty spots. So the little dots are electrons rather than drawing E's because the E's are too big. So in his outside ring, he has 4 electrons and 4 empty spaces. And we just said it's not easier to gain 4 or lose 4. Here's what happens. We do what is called a covalent compound. Co means together. Watch what happens. Somebody like hydrogen comes along. Hydrogen has 1 electron because he's the first element. And he says to the carbon, I'll share with you if you'll share with me. What happens is he puts his electron into that box. Now, this is different than what we've done before. This is like a Lego set. They're actually going to plug into one another. So they plug into one another. Another hydrogen comes along and plugs in here and says, if you share with me, I'll share with you, and plugs his electrons in there. An H plugs in here and does the same thing. And an electron plugs in here as well. Now let me explain real quick. Dots and X's are the same thing. They're all electrons. I made dots and X's so you could tell who belonged to who. The X's belong with the H's. Now look what's happened. This H says, hey, these belong to me, but I'll share them with him as well. I put in 1 electron, he put in 1 electron, and we're going to share those. Now hydrogen's in the first ring, and in the first ring it holds 2. So he looks like he's full. So does that hydrogen. So does that hydrogen. And so does that hydrogen. They all became full. But watch this. I put a big box right here. If we count 2, 4, 6, 8 for the carbon, he's full also. They share the electrons. They count for him and they count for him. So it's sort of like a rope between them. They're attached. And both electrons count for both of them. everybody became full. In this case, it is the formula CH4, a very simple formula. But they have plugged in, and when they plug in their electrons, everybody becomes full. This is what is called a covalent bond. There are no charges. Nobody threw away electrons. Nobody stole electrons to be positive or negative. They just share. When they share, what you'll see sometimes is it'll be drawn like this. Rather than all the dots, which can really clutter up the area, you'll see it written something like this. There's your C, and there's your 4 H's. Remember the biology a little bit. We have really big compounds like C6H12O6, which is glucose. That's just a really big one of these. 6 carbons, and then you put 12 H's all the way around it, and 6 oxygens, and it works out. That's more complex than we have to know right now, but they all do this. Now, hint, if you see a compound that starts with a C, it's going to be covalent. They're going to have to share. Let me show you one other. If we use silicone, silicone does the same thing because they're in the same column. And so let's take silicone. He has 4 electrons in his outside ring as well. 4 empty spots. And when I draw this, you'll remember this from your chemistry class. You take somebody like chlorine, or we'll just take fluorine, I'm sorry. Fluorine. Fluorine is element number 9, so that means there's 2 in the first and 7 in the outside. Watch what happens. A fluorine has 7. 1, 2, 3, 4, 5, 6, 7. Look how many he's got right now. Looks like he has 8. 1, 2, 3, 4, 5, 6, 7. This guy has 7 also. You share with me, I'll share with you. He now has 2, 4, 6, 8 electrons of fluorine plugs in here. 1, 2, 3, 4, 5, 6, 7. Count them up. 2, 4, 6, 8. That guy looks full also. Remember, everybody wants to have the octet rule. They want to have 8. 1, 2, 3, 4, 5, 6, 7. But when he shares with silicone, he has 8. 8, 8, 8, 8. They all look good. Let's check the guy on the inside. Does he have 8? 2, 4, 6, 8. Yeah, he does. So sometimes you'll see this one actually written like this. A line, a line, a line, and a line. The line means that pair that they're holding together. And then they'll put the dots around that go around each one, and you can actually count it. 2, 4, 6, and the line counts as 2, 8. 2, 4, 6, 8. 2, 4, 6, 8. Oops, I didn't put those in the right place. Let me do that again. 2, 4, 6, 8. 2, 4, 6, 8. And silicone, 2, 4, 6, 8. Everybody has the octet rule. Did anyone become +1 or +2 or -1? No, they didn't have to. So how do I know the difference? Very simple to know the differences between them. I'm not expecting you to be able to draw these like you did in your chemistry class. They don't expect you to draw them. But when you see a picture, you can tell it's covalent because they are attached to one another. They are sort of ropes that hold them together. Co means together. So real quick, how do I know the difference between ionic versus covalent? And make sure you write this one down because this will be really important for you. Here's how I know. Look where the elements are located. For example, here is an example of an ionic and a covalent. And if I look at it, I may not know which is which. But when I do this, you will. Take your fingers and you're going to point. Watch what happens. Na is there. O is there. If they're on opposite sides, they're ionic. So we'll go ahead and write that in. Opposite sides. Opposite sides. Carbon pointing, oxygen pointing. If they're on the same side, then they're covalent. Why would that be true? Well, opposite sides are pluses and minuses. Plus, minus, plus, minus, plus, minus. They're magnets. But when they're on the same side, they're going to have to do something else to attach. So they're going to have to plug into each other like Legos. Let me give you two more examples. See if you can tell. See if you can tell which is which. That one? Oh man, this one will be confusing. Got to look at it carefully. Remember, you got to point. SCl2. They're on the same side. That's covalent. BaCl2. Opposite sides. That one's ionic. I'll give you one more and let you decide, and then we'll check it together. Let's see what you get on this one. Write these down, pause it, we'll check your answer in a second. All right, hopefully you pulled your chart out and you looked. AlCl3. Ooh, this one can be confusing. Al's a plus, see where it says right there, plus. Cl's a minus, opposite sides of the chart, that's one of these. PCl5, same side. Well, if you missed it, let me give you a hint. See the big staircase here? That separates the pluses, which are all over here, from the minuses. Aluminum is on the left of that staircase. So he's one of the pluses. Chlorine's one of the minuses. So if they ask you something about ionic or covalent, you can tell by looking at the formula. If you just look at the formula, AlCl3, they're opposite sides of the chart, plus and minus. Oh, they had charges. Yes, they did. How did I get that formula? Al is a +3 that it says right there. Cl is a -1. And remember, you get to crisscross them when they don't equal. That's why that formula is like that. P and Cl5, wow, they're on the same side. So they're going to have a covalent bond. That's how you can tell the difference. Let's talk about names real quick and we'll be finished. They don't ask very many of these, but I want to show you just in case they give you a name. Here are a couple of examples. Okay, you may want to pause and jot them down. Here's how they work. I'm going to start with the second one. This is a gas. Now notice we have carbon and oxygen. They're next to each other over here on the side of the periodic table. And so since they're on the same side of the chart, that means that we're going to have to, they're covalent. So they have to be named different too. Well, this one is called carbon monoxide. Well, you know that mono means one, and there's one oxygen there. This, carbon and oxygen again, there's two of them. This is the gas we breathe out all the time called carbon dioxide. Why is it called dioxide? Because there's two of them. Pretty easy. This top one here has a 5. Remember in geometry, if you have a 5-sided figure, 1, 2, 3, 4, 5, that's called a pentagon. You use pent, so it's called phosphorus. Penta, and what's Cl? Chloride. Phosphorus, penta, chloride. That's how they get the names. And so you don't have to know many of these. I just want to make sure you have a little background. If you see mono, di, penta, tri, hexa in the name, it automatically means it's covalent. They're going to plug into one another. When they're plugging into one another, that's how they make covalent bonds. Just as a reminder, one more time, opposite sides of the chart, automatically ionic. If they're both on the same side, like that last one we talked about, phosphorus and chlorine, then they're going to be covalent. So if you put two of these together, like carbon and bromine, it's going to be covalent. And they're going to have names like this. They don't expect you to know how to name them. Just in case they give you a name, then you know enough to have a little bit of understanding. These are what are called covalent bonds.